Okay, good morning and good afternoon, good evening. Welcome to Indoor Ag Science Café. This is Cherry Kubota. I'm a professor at The Ohio State University. With me, John Otto, graduate student, PhD student, will be who will be co-moderating together. So this Indoor Ag Science Café is information exchange platform mainly for indoor vertical farmers or the technology providers. And then we are doing every month. And funding is coming from USDA NIFA Specialty Crop Research Initiative grant. So thank you again for being with us. So I'm going to hand the moderator role to John. John?
All right, good morning, everyone. Thanks for being with us today at the Indoor Ag Science Cafe. We're excited to have a great meeting today. So there we go. All right, so just an update of the upcoming cafe series. So today is the Indoor Farming Technology Showcase. In July, there will not be a cafe. And then to be announced are all of our presentations for August through December. We have a few potential topics. So talking about perhaps the pros and cons of short cycle production by our OptimIA group, the OptimIA University course review, perhaps having a grower talk, an international speaker or a seed company. If you have suggestions for anything you'd like to see us talk about or feature any potential speakers, please email Dr. Kubota and voice your suggestions. As well, we have an OptimIA events coming up, which you can find at the link below. And as for today, for our Indoor Farming Technology Showcase, we'll have 4 speakers in the following order. So the first will be Kurt Becker with Dramm Corporation. Then the second will be Chris Higgins with Hort Americas, followed by Paul Ken of Quantified and Vijay Rapaka of Smithers-Oasis. And so, anything you'd like to add, Dr. Kubota?
Yeah, so this is our second series of indoor farming technology showcase. And the first one was very successful, in my opinion. And then I like to have periodically this opportunity so that you can learn the most updated technology information. So, all right, good. So I guess that's it. We can start from Kurt presentation.
Great. Okay. Thank you very much, Jerry and John. I appreciate you guys inviting us to do this. Dramm is now celebrating our 80th year, and it started with the invention of the 400 AL water breaker, which is what you see on the screen. As a company, our whole approach has been to try and improve the way that plants are grown, the way that water and liquids are delivered to plants, primarily through irrigation, through humidity, but also through spraying and technology. Throughout our entire history, we have really focused a lot on spray equipment. And, we look at the basic equipment that most people use, hydraulic spray equipment. So that's anything that we're pressurizing a liquid and pushing it out through a nozzle to create a droplet. We make a lot of equipment that fits into that range. We also make fogging systems for greenhouses and indoor growing. These are creating just finer droplets, but it's still liquid delivery. All of these systems, are meant to, again, apply a pesticide, a plant protectant, even a fertilizer to the foliage primarily. And then we do make some that are meant for sanitation, foaming, things like that, but also for delivery to the root zone. So we can put liquids directly into the rhizosphere, generally at regulated doses, so that we can make sure that the plants get the right amount. One of the things that we've seen, particularly in the indoor space, as we're, Dramm traditionally began in more of an ornamental role. We've spent a lot more time in the last 20 years in the vegetable space, and you start to see that plant height, plant density changes a lot depending on crop. We've got plugs, we've got tomatoes. So we've got a very different range of targets that we need to be going after. And one of the things that we've been working on the last couple of years is improving the ability of a regular hydraulic spray to do more targeted applications, and depending on the different heights. So if I'm spraying a horizontal crop and we want to spray downward into that crop, or I'm spraying a vertical crop, we're looking at ways that we can target the plant better, generally use less liquid so that we have less runoff, less drift, put it where we need it to go, but still make it effective. Technology that's been around for a number of years is electrostatic charging of droplets. And traditionally, this has been done where we take a solution and we push it, we pressurize it slightly through a nozzle. We add air to that, and then we add high voltage. This is the way that most electrostatic sprayers work these days. And the result is you get a whole cloud of charged particles, either negatively or positively, depending on the setup of the induction process. But we're looking at charging droplets negatively. And then what happens is when they approach a target that is grounded, those will take that surface will generally take the opposite charge and attract those droplets. This, again, as I said, is nothing new. This is not new technology. This was developed in the 50s originally, and it was really developed primarily for outdoor row crops. And the idea was trying to prevent drift while also producing a better coverage. What's really important about this, though, and where we want everybody to understand the science, is that it relies on a couple things: grounded target, and then density of the crop is always an issue. What we've seen in the greenhouse industry is that a couple of those things aren't always true. In crops where we're growing on plastic tables, or we're growing on, we may not be all that well grounded. And so the grounding effect, that charged effect of the droplet flying and being attracted to the surface, is lessened greatly when there's less grounding. So, when we look at the different ways that this type of system works, is a negatively charged or a charged droplet is going to be attracted to a surface that's grounded. Once we remove that, there's still some benefit, but it's not as strong. The second thing that we see when we look at electrostatics is that is a benefit to the spray application process, is that when we have all the droplets the same charge, they repel each other. And so one of the benefits of electrostatic charging is that we can create finer droplets, because what happens when we spray is typically we are creating bigger and bigger droplets, primarily because we're using water as a carrier. Those droplets recombine over time. They snowball, they get bigger because droplets hit droplets and they become bigger droplets. When they're all charged the same, they repel each other, and you don't get as much recombination as you might when you don't have that charge. So one of the challenges we'd always seen in electrostatic charging is that, or the two challenges, is that the target's not always grounded, but more importantly, the air atomization effect, the way that this is being applied to the crop, is typically not forceful enough to push through a dense canopy. Works really well on plugs and younger plants. Once we start to get any canopy at all, there's generally not enough force from these nozzles without adding air or something else to help drive it in, to get those droplets to spread throughout the canopy so that they can attract all the surfaces. So we've been really looking at, instead of an air atomizing system, we are working with a hydraulic application where we're reducing the flow through smaller nozzles, but we're adding the charge without the air. And so we're relying on higher pressures to generate the smaller droplet. And then we're producing an electrostatic charge on that using a similar style induction ring. The result is that we are getting finer droplets. We're getting a good amount of force, though, that helps drive it into the canopy. What we're finding, though, is, as I said, that in a lot of the crops that we're dealing with, so we're going to be, if we're working in a vertical situation, or we're working in, with a vine crop that's grown in rock wool sitting on, they're not well grounded. So our focus on this is trying to produce finer droplets with a good force that can enter and enter the canopy and spread throughout it with some attractive qualities. And so just wanted to show everybody, this is kind of what we've been able to demonstrate so far just by working on this process. We take hydrosensitive paper, we put it into a plant, and we spray using different rates of charge, different flow rates. And this is about one of the best things we've seen. So this is without a charge. You see the hydrosensitive paper was placed away from the spray. That's basically being sprayed from the backside. When we apply the charge to the same nozzle array, that's what we get. So we are getting finer droplets, and we're getting some wraparound as a result. Like I said, it's not fully grounded, but the advantage is that we can produce better coverage with a hydraulic spray by adding a negatively charged induction ring to the nozzles. So we're focusing on this in these spaces because what we're seeing is it's difficult with a lot of these crops to get good penetration, good coverage when it's needed. So as we continue to develop this, we're still working on reducing the flow to these nozzles. We know we need to add some structure to it to make sure that those wires carrying high voltage are not exposed. We want to protect the nozzles, but we also want to make sure that we're not causing any thing to snag on as we move through the structures that we're spraying. And then finally, we're looking at different types of nozzle arrays, one for flat horizontal surfaces, but also some for taller crops. So we could envision this being mounted on a spray rig on pipe rails, or we could envision this being added to maybe a horizontal boom type structure that would spray vertical crops or horizontal crops. So that's our development in this area. It's interesting. We've seen electrostatics gain a lot of interest in the last couple of years, mainly because people are using them to spray down surfaces for sanitation. But it's something that we want to make sure everybody understands. It's not magic. It's not, and that's what everybody tends to think, is that this is this special charged droplet that's going to be magically attracted to the plant. And given a lot of the issues we have or limitations we have in greenhouses, we're kind of going for a lower bar, but we think we can do a better job with regular spray technology just by adding this type of induction. Any questions?
Oh, I have one to lead off, perhaps. So in greenhouses, you said there are a lot of the structures are not well grounded. Are there any examples in those systems where the structures are particularly well grounded in those kind of systems?
Actually, the structure itself is grounded. It's going to be we're growing quite often in a sterile media in a plastic pot sitting on potentially a plastic bench. That's just layers of insulation between, now that might be sitting on steel legs that's bolted to a concrete surface. So there is grounding, but it's insulated every time you add things like plastic. If, we're growing in the ground, or if you're growing it, the problem is that there's just going to be limitations to that amount of grounding, which is what we've seen with electrostatics over the years. And the challenge was always that you couldn't get enough force to drive into the canopy, and everybody was relying on this magical charge to kind of navigate through the leaves to get inside. And it really needs some type of force to help propel it to get that benefit. And so that's why we're taking this different approach of using hydraulic nozzles to do the job without their atomization, but also recognizing that that magic charge isn't quite as impressive as it might seem. I remember 20 years ago, people putting an apple on a metal stake that was grounded to the floor and spraying it with an electrostatic nozzle using things like diatomaceous earth, which takes a charge very well, and just coating the entire apple with a white surface, with a white coating. And that's not really indicative of what's going on in most of our crops. And so we're trying to take this to the next level.
Gotcha. All right. Thank you for that.
So the plants, you want to spray over the plants, but not the panel surface or flame of or lighting, right? So that's the challenge.
Sure. That's also an issue, is that, we have a small targeted area sometimes to be able to spray. And it depends on the cropping system, obviously. But one of our goals with using smaller droplets is that we can use less liquid typically to deliver the pesticide, which means we don't have it running off as much. We don't have it over contaminating different areas and things. We want it to go where it's needed and not a lot of other places if we can avoid it.
Right. Thank you so much.
Well, thanks a lot. Appreciate you having me.
John, shall we next to the next speaker?
I think so. All right. So thank you so much, Kurt. Up next is Chris with Hort Americas. Chris, if you want to share your screen.
All right. First, Dramm's kind of got Hort Americas by 67 years. So Kurt, you got a little bit more experience than I do in the space. Your company has a little bit more experience than we do. As Hort Americas got, we officially started in 2009. So we're on year 13. What I wanted to do is, even though it feels like I constantly talk about Hort Americas, I wanted to make sure that everybody has a good understanding of all that we're involved with and what we are up to. So Hort Americas, as I just stated, has been supporting CEA since 2009. We have looked at a couple of different areas in the space, that being, we are doing vine crops, which peppers, tomatoes, cucumbers primarily. We've spent a lot of time looking at leafy greens and culinary herbs. We are also still working in the ornamental industry, and now more and more looking at strawberry production inside of controlled environments. We really have taken to heart over the entirety of our business, the idea that this is really a team approach for us. And in that, we're looking at the partnerships we have with our growers, the partnerships we have with our vendors, and the partnerships we have with leading industry professionals and researchers at different universities. Hort Americas is part of a Dutch investment cooperative, as well as myself and one of the owners. We are based just outside of the just inside of the Dallas-Fort Worth area in Bedford, Texas, which for anybody that doesn't know is very near the DFW airport. Technology is what we're focused on, but it's only as good as our ability to use it. And so in getting to better understand where we're coming with technology, we're really focusing on collaboration, partnership, and then sharing of that information. It's important for us to feel like everything we're doing, we can provide the whole story. And that means not only how you use it, but what it took to create it, what data we have supporting it, and how we're going to share that with the industry. This means we're ultimately a service business, and we have strong technology partners. Within our team, we definitely have people that know how to use the technology, which leads me to the first part of our business, which is our tech service area, which is led by Carla Garcia. We've spent a lot of time over the last few years developing information that allows our growers to be more successful, we feel. You can find this information by visiting our YouTube channel and looking at our mastering series, in which Carla tackles many of the technical problems, technical issues that growers face on a day-to-day basis, and we provide information on how to solve those problems. We've put a lot of this information into books. We've got a book on tomato production. We have a book that we did with Farmer Tyler on growing leafy greens and culinary herbs. We have some guides to growing, and we also host webinars, or short courses, if you will, online about once a month. Our mastering series is now over 35 videos, in which we tackle primarily controlled environment ag crops like leafy greens and vine crops and strawberries. In that, we try to break them down into very specific topics and try to keep the videos less than 20 minutes so that we don't lose anybody's attention. So anyhow, let's get starting over here with this lighting and learning event. Restating what I was in the process of saying is that at this event in North Carolina, we're going to be joined by Dr. Kubota, Dr. Hernandez from NC State, as well as some other presenters from leading universities to find out the latest on where we're at with research for horticultural lighting. We're definitely going to explore strawberries, other vegetable crops, and we're looking right now to fill that in with some ornamental research as well. So I'm going to jump ahead just to catch up on some time here. Hort Americas really kind of views our role in the industry as somewhat of helping develop technology within the space. So here's how we look at our role in developing technology. Number one, we want to work with the growers to understand what their needs are. We want to understand where they want to go. Then we want to understand the plant science behind these needs. We then look towards the global industry to find out if any products within this space exist. If they don't, or if they do, we identify the suppliers that either have the product or are capable of developing the product. And then we want to work together with that supplier to get the product to the industry and then help the grower be successful. A really easy example for me to show is how we did this with LED grow lights for the greenhouse industry. In 2020, we started working with App Harvest to develop what they wanted, which was a reliable supply of a North American built LED grow light at competitive prices with leading specifications. One of the reasons they wanted to do this is they wanted to create jobs in their region. But they also wanted to look at managing supply chain lead times and better working to support them with after sales service. And just so happened that we were able to do this in Hendersonville, North Carolina. We have now since taken that model and created some indoor farming lights using the same strategy. So here's just two pictures of the two products that we are now making in North Carolina. The one on the left you'll see is the L1000, which is our greenhouse option, as well as the one on the right is what we call the Factor, and this is a high output vertical farming option. I think a lot of people in this call recognize Hort Americas for what we've done in lighting, but I also wanted to kind of quickly dive into what we've done with other products. We've done the same thing with substrates and fertilizers. We worked with a Dutch orchid grower years ago to look at bringing a very simple, what some people thought was a very simple product to North American supply. If you know anything about the orchid industry, you'll understand that the orchid substrates the Dutch use is a pine bark substrate. In the United States, we do have pine bark as an option, but it is different than what they have in Europe. So we, together with a couple of partners, looked at developing a substrate that had the similar characteristics of the European pine bark and the European orchid substrate, and then created that product again in North Carolina. It may seem like we're doing a lot in North Carolina. This is all by chance, not by design. We've done the same thing for the strawberry growers in California, looking at developing a custom strawberry trough that fit multiple different tabletop designs or gutter designs. And once we're able to get the volume up to a reasonable amount, we do have the ability of bringing that manufacturing to the US as well. Another space that we've continually looked at is the fertilizer industry, wanting to bring down the cost and make the product stay in the system longer. So Hort Americas developed our leafy green mix. This is really based on the way growers are growing, not necessarily specific by crop, but looking at creating a fertilizer solution that will stay in solution longer, thereby being able to save cost and not change your fertilizers as frequently. The next one we're trying to tackle this with is on the organic side. We have been working with an organic fertilizer preempt for quite a few years now, and we're looking at bringing in a dry product that we can incorporate into the substrate this year. We're going to start doing testing and trialing with key growers next month. So the last thing I want to talk about with Hort Americas is our commitment to change. So what we're really looking at is bettering ourselves within the communities we work within. So as we did with the LED grow lights, we want to create job opportunities, not only for our growers, but with inside the manufacturing organizations that we're working with, support community-based food projects, and consider the impact that we have on the environment. The last one I'm learning is probably our hardest goal. Examples of this would be again, referring back to the GE project we did in Hendersonville, North Carolina. Many of you know that we work with the State Fair of Texas to demonstrate a lot of the products we sell. All the produce we grow there goes to the local community to support nonprofits, as well as looking at the way we work with California berry growers and being able to collect nitrogen before it runs off and allow the growers to treat it and dispose of it properly. So with that, sorry for the slight technical error, but that wraps up my presentation.
All right, thank you so much, Chris. I think we'll have time for a quick question before we jump to the next speaker. So Chris, when you were talking about the leafy greens mastering series, does that include kale in the CEA leafy greens category?
It does. It is one of those things where we try to address topics that people bring to us. A lot of what we've developed has been based on hearing from the growers that say, can you provide us more information on this specific area? Kale for us has not been one of the crops that we get a ton of questions on. It is kind of cycled along with a lot of the other plants. For a long time, we started just with head lettuces because that's what everybody was growing, either head lettuce or basil. Then everybody moved to, let's call them baby greens or teen greens, teen leaf greens, depending on the terminology you want to use. Now it feels like we're moving into other crops again. So I'm sure the information that we're going to develop is going to have to change quickly in order to address the needs as those crop selections change.
All right. Well, thank you so much, Chris. All right. It looks like we'll move on here to Quantified by Paul Ken. So Paul, if you'd like to share your screen here, make sure everything looks good.
Okay, thank you very much. Appreciate it. Happy to present here on behalf of Quantified Sensor Technology, dialing in from Holland, Netherlands. And special thanks to Professor Vijay Rapaka for offering us the opportunity. So these are the topics that I would like to share with you. And at the end of the presentation, I'm happy to answer any of your questions. So talking about Quantified Sensor Technology, we're based in the city of Leiden in Netherlands, which is very close to the Westland area, which is basically a concentration of about 4,000 hectares of high-tech greenhouses. And we started the company in 2018 in this area, basically from a scientific background and with a focus entirely on agricultural markets. And we have a strong belief that sensors can really help make the ag tech sector more sustainable by reducing energy and water and crop chemical usage by data gathering and data analysis. So what do we do and what makes us unique? Basically, we design and manufacture robust scientific grade sensors for harsh agricultural environments. We do that for the subsectors here you can see below. And what is really difficult is, so basically what is not so difficult is designing a sensor electronics. But what is really difficult is to manufacture sensors that generate accurate scientific grade data over a longer period of time under those harsh conditions. And that is what we are really good at, combining these three elements of excellent electronics design, but also sensor housing and guaranteeing data quality and data integrity over at least a longer period of time. So we started producing wireless sensors, both custom to customer specification, but also off the shelf. And I will talk about our portfolio in a later stage. After our wireless sensors, we also started 2 years ago on producing wired sensors, specifically for the controlled environment market. because in controlled environment there is always, or there's mostly power available, and also connectivity is not so much of a problem. So that's where we really make custom-made wired sensors, because every, let's say, grower has its own technological setup. So also the sensors there are custom-made. Talking about our wireless sensors, basically it's based on a radio frequency transmission, and we use the LoRaWAN communication protocol. LoRaWAN is a low power, long range protocol, which basically means that with very small amounts of electricity power, ranges between 400 meters and 5 kilometers can be reached. So 400 meters would be typically in a greenhouse or in a vertical farm. And depending on obstacles outdoors, you could easily reach 5 kilometers. We have a typical measuring interval of about every 5 minutes where the data is generated, which leads to a battery life for the wireless sensors of about 9 months. So the sensors are typically in this let's say greenhouse or a vertical farm, and they are sending through the LoRaWAN wirelessly to the gateway the data. So the gateway is something like you would have for Wi-Fi a router, like you would probably have at home, and the gateway sends the data to the internet. It's connected to the internet, and in our case, we are using Amazon Web Services to basically store all the data that is being generated. And from there, the data can be either accessed for visualization, for downloads, or we can do that with our, let's say, our own platform, but we can also connect to any third-party system with an API. So what is interesting talking about wireless sensors is that, of course, there is a lot of sensors already in the market. Typically, you know, the big players that have the climate sensor, the climate box inside of a greenhouse. But the wireless sensors can be really an addition to these kinds of measurements, because with a wireless sensor, you can do a 2D distributed measurement, and really start looking at climate uniformity within the growing area. Then moving on to the wired sensors, which is not so complicated. Of course, these sensors are wired, and depending on the wishes or the demands or the specifications of our customers, we can implement any communication protocol that is desired or being used momentarily. And then the data is, of course, transferred to either the climate controller or data storage for later analysis. So, like I said, looking at our portfolio, this is only a wireless portfolio, because all the other developments in the wired section are custom made and are not in a portfolio. And we'll share a few examples. So if you would like to see our entire portfolio, you can go to our website. It can be found over there. So first is our Firefly sensor node, which is basically a platform sensor. It has a battery inside, and also a transmission module, the LoRaWAN module I talked about earlier. So this sensor can send any data to the gateway and to the internet. So let me see if I can get, okay, well, you probably can see my cursor. So here's the connector to this sensor, which is basically being used for charging the battery, but it can also be used to connect external sensors. And those external sensors are developed mainly to measure very specific types of parameters. The platform node, the Firefly, also has some, let's say, onboard optional sensors. Here behind this little window, there is a PAR light sensor. Then we have a GPS module here in the middle. And behind the membrane, there's a temperature and relative humidity measurement. So this mother sensor can be connected to the slave sensors. For instance, our solar chimney would be such a slave sensor. As you can see, it does not work standalone. It has to be connected to the Firefly sensor. which takes care of the data transmission. And a solar chimney is typically a naturally ventilated high accuracy measurement for relative air humidity and air temperature. And we do have some options depending on the situation where the sensor is being used for mounting the sensor either on a pole or on wires or sticks. Then moving on to another external sensor, which is our Poseidon multi-depth sensor, which is a soil substrate moisture, electroconductivity and temperature sensor. There's an option between either 1, 2, or 3 probes on this sensor, depending on whether you want to measure multiple depths or maybe multiple pots. And also here, this sensor is connected to our Firefly platform node. And maybe a last example within our portfolio is scales. So we have developed different scales depending on what kind of potted plants are used. These are typically being used by growers to optimize watering strategies. And these are all resistant also for wet and harsh environments. With weight ranges between 9 and 90 kilograms. Okay, so maybe summary. What we do is we design and manufacture. We manufacture everything in Holland, Netherlands, robust scientific grade sensors for harsh agricultural environments. We have wireless sensors for distributed management measurements and 2D visualizations. Also wired sensors for controlled environments specifically. And that's what we do. So happy to answer any of your questions.
All right. Thank you so much, Paul. We are running close, so I think we can fit in 1 or 2 here on the side if they're quick. So I have a couple questions from Ed Weinberg asking about are lithium-ion batteries used to energize these sensors, or how are they powered when they're
Yes, these are lithium-ion batteries, actually the exact same ones that are being used in a Tesla battery pack. Yeah.
Okay. Also quickly, does the Firefly monitor CO2, or is that an additional sensor?
It's an additional sensor, and actually we're currently developing that one. It should be ready next month.
Lovely. All right.
I have a question, Paul. So you said that you have a API to communicate other controllers, but I just wanted to know if you have already API to communicate with sort of major greenhouse controllers, or
yes,
is it available?
It is available and it's also functioning. Actually, we use the same API ourselves for our platform. And we have a connection. I don't know if you know platforms, Dutch platforms in the US, but Let's Grow is a platform that we are connected to, and also some other smaller platforms that are being used for specific markets. Yeah.
Great, thank you.
Welcome. Thank you very much.
All right. So last up today, we have Vijay Rapaka from Smithers-Oasis. And so if you'd like to share your screen and
Dr. Kuba, thank you very much. I appreciate the opportunity and really enjoyed the overviews from Kurt, Chris, and Paul. So this is the last one. Actually, today we're going to talk more about our recent introduction, which is HORTICUBES AEROMAX. And this is an engineered substrate exclusively developed for precision farming. And yeah, my name is Vijay Rapaka, and I manage the research and development globally for growers side of the business. Just really quick into some brief overview about the company. This is a 1938 first introduced flower food for the cut flowers, and then 1954 introduced first water absorbing foam for cut flower arrangement, and in 1969 is when we introduced our first first engineered substrate for propagation of ornamentals. So I've been in the industry for quite some time, dealing mainly with the floriculture crops and all that stuff. But in 1980 is, I believe, when we started with the HORTICUBES, and that's what we started participating in the hydroponic industry and all that stuff. So if you look at Smithers, we have 6 business groups, and Oasis Grower Solutions is one among them. We have a wide variety of other business that is dealing with the cut flowers, temperature control management, and all that stuff. And if you're, you can see more of that information under Smithers-Oasis.com. So today, actually, we manufacture in 19 different countries, and we have several sales and distribution centers all over the world. And we have 9 research facilities also spread over. And one of the core strength is that our global footprint and collaboration with the university researchers and also with the vendors and the customers and all that stuff. That has been one of our core value, core strength, and that's we always continue to further nurture on. Then quite quickly switching into the main topic. So enough of that introduction, right? So just quickly, just categorized into 2, direct and indirect. And direct is everything obvious for everybody. So physical support, the substrates, again, provide water, oxygen, nutrients, holding and shipping of the young plants, facilitates handling and sorting, automation, and all that stuff, minimize transplant shock and grafting and growing specific plant types if you're doing with tomatoes and or melons and all that stuff. Indirect, this is also extremely important, as important as the direct, is that shoot and root architecture. The substrate has a profound impact on that. The density, the strength, or the color of the substrate also has a profound impact on the architecture of the plant. The cleanliness, if the plugs are staying too wet, again, it promotes algae growth and all that stuff. And of course, there's a lot of organic matter promotes algae, fungus gnats, and all that. So that's also an important thing. And then lastly, steering of the plants between vegetative and reproductive, depending on the air porosity, how much air and water, and also depending on the how quickly you can manipulate the EC in the root zone, that can affect all that stuff. So these are all the main things that are looking at the role of the substrates. And our substrates are widely used for a wide variety of applications, propagation of ornamentals to propagation of lettuce, and also used for tomatoes and peppers and all that stuff. But today, I'm going to focus mainly on the leafy greens. And again, this includes lettuce, basil, cilantro, or kale, or whatever you're looking for. Typically, this is the journey. Again, propagation, depending on the size of the propagation tray, you're using 12 to 18 days in the nursery. And after that, they're transplanted into NFT raft system or aeroponics or whatever it is grown. So just quickly diving into the what is this engineered substrate? Actually, it's a thermoset phenolic cellular foam. This is how it looks like. And if you look at the closed microscopic view, this is how the cells look like. The water can get in, only certain water can come out, depending on how we program, engineer the cell structure and all that stuff. So optimal air-water ratio, no buffering capacity, so easily you can change the pH and EC. Structurally stable, do not compact during production. That's one of the key things. Available in various drainage options. So depending on the crops you're growing, depending on the climatic condition, we have options. And the important thing is that this arrives clean, free of pests and pathogens, and also allows for clean and safe production of crops. Here, these are our offerings. HORTICUBE, this is one of the original one. HORTICUBES XL, the one is a higher drainage, lower density. The other one is a lower drainage, means holds more water. And in 2010s, we released this HORTICUBE ES, ecologically sustainable. This is the certified biodegradable engineered substrate that is available in the industry. Again, this degrades about 86% in 90 weeks in an anaerobic environment. And our most recent introduction to the market is that HORTICUBES AEROMAX. This is the product that got launched in 2021, has a higher drainage. And one of the key things is that it has a ultra low density. Just quickly walking through some features and benefits. Maximum airfill porosity means more air, means more oxygen, promotes healthy and profuse root growth, and it's about 15% compared to 10% for the most of the propagation media in the root zone environment. And it's because of the open cell structure, allows for rapid nutrient refreshment. Whenever you're putting new nutrients, it's always refreshed with the nutrients, that is solution that is rich in oxygen and all that stuff. You can remove the old really rapidly. Ultra low density, that's one of the key feature of this. What it promotes is that, again, if you're looking at peat-based media, typically it is around 80 to 100 kilograms per meter cube. This is 14 pi times less, allows for easy root penetration and also promotes rapid growth of the plants and all that stuff. We have the ability to change the color after looking at different colors, and we optimize with the black color because actually we noticed that it can increase the surface temperature by a couple of degrees, especially when you're growing under LEDs, and also promotes well-toned plants. Our original color used to be brown color, so this is the new color we came up with. And drier plug surface, this because of the higher drainage, we can minimize the algae growth and keep the surface dry. That's one of the key feature and benefits of this new substrate. Applications, wide variety. You can use in greenhouse and also in the indoor farming setting, ebb and flood and NFT and all that, and also wide variety of leafy greens could be grown in this substrate. Just quickly to show you the overview of how this new AEROMAX is performing comparing to the previous generation. This is HORTICUBES XL. You can see that the growth is significantly superior and also well-toned plants, uniform, consistent, faster growth, well-toned plants, less algae, no vermiculite top dressing required, 15 to 20% faster growth compared to the previous generations. And this comes in wide variety of configurations. There are 50 count here and 276 count. This is the high density propagation sheet, and this is the lowest density. Comes with single seed, multiple seed. Also, we could do customization depending on the grower applications and the size and all that stuff, business volume. So there are several options that are available. And what is the best option always is the question. So I'm actually going to answer that in the next slide. So this is so how to maximize the profitability. I think this is really important. Choosing the right configuration is the key to maximize the efficiency and throughput. So basically, that's a loaded statement. Let me unpack that for you here. Here on the left side, which I'm showing is the different configurations that I talked about: 276 count, 162, 104, and 50, and number of days in the nursery, 12 days, because the small high density propagation, small cube, you can't go beyond 12 days because otherwise it'll be competing for the light and they'll start stretching. And with the largest plug, you can go as high as 18 days. Or again, depending on the light levels, you're providing CO2 and all that stuff. So this is what it is. These different size plugs are spending in the nursery, and also then this is how many days they're spending in the propagation or the finished area. And if you look at the total, it's always 30 days. Then when we harvested this crop, if you look at this on the right side, basically there is no significant difference between the head weight between 276, 162, 104, and 50. So here, the take-home message is that if you're doing with the high-density propagation cube, of course, you can have it through faster turnaround time in the propagation area, but they're going to spend a lot more time in the production. Right? And also, if you look at the opposite, if you are spending highest time in the propagation, they're going to spend lowest time in the production area. So we got to choose. It's always choosing the highest density in the propagation is not the best, and probably choosing the highest plug size, the biggest plug size, and then spending minimum time in the production may not be the best also, because you have to 4 times increase your propagation space. Maybe somewhere in between is the right amount of time, because again, So the journey throughout the system is extremely important. Your production area is the highest value because that's the highest dollars you're going to spend per unit square foot. And then you need to think through what is the layout should look like, what is the flow through and all that stuff. That's very important when you are choosing. So that's the statement, choosing the right configuration is the key to maximize the efficiency and the throughput. I think last slide, or maybe last before one, this is just AEROMAX has been a very big success for us. This is one of a product in usage at one of the largest leafy green producer here in the United States. And also just a slide with basil, not only lettuce, basil, kale, cilantro, pretty much everything. You could use this for propagation and production. Yeah. And yeah, that's actually wraps up my short talk. And there's again some, if you want to reach us, that's the information right there. Let me move my, any questions?
Well, thank you so much for that. That was very informative and actually pretty interesting. I do have just a quick question. What, when you were doing that comparison slide of the number of days in production versus the number of days in propagation, what system was it you were growing in, and what environment was that carried out?
Yeah. This is actually, this was done in a greenhouse with supplemental lighting, and actually light levels were around maintaining around 400 to 550 micromoles. When it's lower than 300, we were turning on the lights and all that. And it was done in NFT system. And this was done during the early summer, late spring. Actually, we have seen really some other interesting things we want to further explore. Actually, the shape of the head is also quite different. If you're dealing with a smaller plug size, the shape of the lettuce is more tall, and we are seeing actually a lot of boundary resistance, and we have seen also a tip burn. Whereas if you spend the young plants for a longer period of time in the propagation, the heads are more open because again, it looks like it's spending less time in the production and all that stuff. And we have seen also less tip burn and all that stuff. We want to explore a little bit more into that, but that's about the details. Yeah.
Awesome. Really interesting. So can you provide some more detail on the ES foam material? I think that's the, was that the biodegradable one, or was that the,
Yeah, that's
okay.
That's actually it's also made with the phenolic foam, phenolic resin. And it is biodegradable about 95% in 80 weeks in a landfill, actually anaerobic environment. And that's one of the new introductions. I mean, not new anymore, again, 4 or 5 years ago, but we are also working on the new AEROMAX technology to be actually compostable. That's still in the pipeline, probably. We would be doing some field trials and all that stuff later this year or next year. But the one US is an ecologically sustainable foam. The performance is still pretty comparable to the HORTICUBES and all that. And you could grow leafy greens and propagation and then also, of course, you could do tomatoes and also all that with that.
Great. Another question, have any of your customers used optimization theory to make the best cell count choices, or how do you recommend that they figure out what?
Yeah, great question. Actually, most of our early customers are with our high density 276. That's what they, because it's the cheapest plug. And of course, when you're, the inputs are less and all that stuff. And later on, or the last 3-4 years, we have been doing a lot of optimization work with our customers and all that stuff. Most of the customers are using 104 count. And that has been working very, very well for most of the customers. And actually, we are in the process of coming out with the singulated plugs that's still in progress. And then we could do, fewer sizes, more sizes, like again, looking at like 72 and all that stuff. It's not always the same size fit everything, because if you're doing head lettuce, it could be different, or if you're doing multi-leaves, it's different and all that stuff. But in general, to summarize, 100 has been 104 has been our most popular configuration.
Well, thank you very much, everyone. So this is the last chance to ask quick question to any of the speakers. It was very interesting, and I really appreciate. One of the things I have as a mission is cultivating innovation platform, and then also R&D capacity in North America. And I hope this is a sort of stimulating positive influence for everyone to evaluate good technologies, to use good technologies, and promote good technology and develop good technology. So that's some of the things I wish to see in coming years. Already happening, but I'd like to promote more. And then I really appreciate today's speakers, 4 of you, sharing that with us. And then thank you, everyone, for being with us. And thank you, John, to deal with me and all the time, everyday basis as a graduate student. And thank you. So have a great afternoon or evening, everyone. And see you, I guess, in August, because we don't have July Cafe. So thank you.